Okay, so guys, today we're going to be doing a lesson on steep level turns. Okay, so essentially, pretty much the aim of this lesson today is for you to be able to learn the aerodynamic principles and the considerations involving conducting a steep level turn, and then, as always, how to conduct them correctly and safely as well. Okay? In terms of practical applications or reasons you might want to use them, first is an evasive manoeuvre. Okay? Now this isn't actually as cool as it sounds. This is more like if you want to avoid an aeroplane coming to near you or a cloud or any sort of other obstacle quickly, then a steep level turn is something you can use in that case. So practically it is actually quite a useful manoeuvre. And in terms of other things, a control coordination exercise. Now as you learned in medium level turns, you get pretty good with your control coordination while doing a medium level turn. This will make that even further. Okay? So you'll get even better with your controls in this case as well. In terms of some new definitions I'm going to have to touch on today for this lesson, we've got a few here. Now the first definition is actually that of a steep turn. Okay? Now whilst it's pretty much self-explanatory, it's basically a turn in which the angle of bank is at least 45 degrees. Okay? So today we're going to be looking at two different types of turns, one at 45 degrees angle of bank and one at 60 degrees angle of bank as well. Okay? For example, we've got our aeroplane here, flying along away from you, and this blue line here, seen behind the aeroplane, is the horizon, okay? So to put it practically, that's what a 45 degree angle of bank turn looks like, okay? So it's pretty steep. Alright? The next definition is that of load factor, okay? Now load factor is basically lift over weight, okay? So it's a ratio of lift over weight, and it's measured in G numbers, okay? Now, have any of you guys heard of G's before?
Yep.
Yes.
Okay. Do any of you guys have a good idea of what it is?
Yes.
Okay. What is it?
Well, 1G is the gravitational force that we experience on Earth.
Okay, that's good. Sometimes when you might feel different G's would, for example, be on a roller coaster. You guys have all been on roller coasters before yet?
Yeah.
Okay. Now when you're on a roller coaster, because this is, remember, a ratio. For example, when you're on a roller coaster, you know how you get down to the bottom and then you start to come up really quickly, you start to feel very heavy, yes?
Mm-hmm.
Okay. So when you get to the bottom there of the roller coaster, it starts to come up quite quickly. You're being lifted up very fast, and basically lift might, for example, double. So we've got 2 over 1 instead of 1 over 1 lift weight, so you're going to feel double as heavy as normal. So 2G, or 2 times the force of gravity, as Tim said before. So this is something you're going to be experiencing in a steep turn, something we'll touch on a little bit later in the lesson. In terms of some revision that we need to touch on before the lesson, we're going to be revising a little bit of stuff from medium level turns, and then we'll be moving on to the principles, so the real meat of what actually happens in a steep level turn, okay? Firstly, we're going to revise the forces in the turn a little bit. Okay? So we've got our aeroplane here, Cessna 172, and you can see that from where we're looking, it looks like it's flying away from us. And right now, we can assume the aeroplane is in level flight, okay? Now, Tim, can you tell me what this green arrow pointing down from the aeroplane is representing?
The weight.
Okay, good. The weight of the aeroplane. Next, Michaela, can you tell me what that blue line there is representing?
Representing the lift.
Okay, good. Representing the lift force. Okay, we have this black line here representing the vertical component of lift, okay? What this means is this black line represents the amount of lift as required to overcome weight, okay? So right now the blue line is equaling the vertical component of lift required to overcome weight, so the aeroplane flying in level flight, okay? Just a representation. Now if I bank the aeroplane over to the left, what do you think is going to happen to that vertical component of lift? Or better yet, what do you think is going to happen to lift? Do you reckon it will stay pointing straight up, or do you think it will bank with the aeroplane, Mum? Lisa?
I think it'll bank with the aeroplane and be less, it won't reach that black line.
Okay, good. That's precisely what's happened, okay? So it's banked over there with the aeroplane, okay? Now what's happened to the vertical component of lift, Tani? Has it decreased?
It's decreased.
Okay. So with that in mind, Tim, do you think this aeroplane, if we do nothing else, if we just stay like this, is going to stay in level flight, or do you think it's going to descend?
It will descend because the lift hasn't enough lift to equal the weight.
Okay, precisely. That's exactly what's happened, because now we've got a vertical component of lift and also that horizontal component which pulls us into the turn. Okay? Now in a medium level turn, as you remember from before, we actually increase the angle of attack, so we pull back, and that basically provides more lift. So the vertical component of lift again equals weight, and we're in a turn flying and level flight as well though. So maintaining our altitude in the turn, okay? So that's basically for medium level turns. Let's now move forward a little bit and go into steep turns. So moving a bit further forward than this end. Okay? So now for example, this aeroplane, let's say we're going to go further than a medium level turn. Let's say we're going to go all the way to 60 degrees here, for example, 60 degrees angle of bank. Now that's quite a steep turn. Alright, so Mum, what's happened to the vertical component of lift now?
Well, it's reduced even more.
Yeah, okay. It's actually, in fact, half of what weight is basically. So we're going to descend quite quickly, you can imagine, if we don't do anything about this. So what that means is we need to double the amount of lift being produced. Now remember we talked about G's a little bit before? If we're doubling the lift compared to what the weight is, we're going to feel 2 G's. And interestingly, that's what we feel in a 60 degree angle of bank turn, okay? So at 60 degree angle of bank, lift needs to be doubled for the vertical component of lift to overcome weight. So simple enough there. Okay? Now in terms of the principles, we actually need to talk about these forces in a little bit more depth, okay? Now have you guys heard of centripetal or centrifugal force?
Yes.
Okay. Anyone else? Okay, so let's talk about that a little bit. We can try to inform you a little bit more as well, Tim. Okay? So for example, we have a diagram down the bottom here. Okay, now it looks a bit confusing, okay, but what this basically represents is, let's say the aeroplane is over here, aeroplane is here, and it's flying up in this direction, right? Now this is the turn, the axis here, and this is the aeroplane's direction of rotation. So basically we've got an aeroplane here, and it's going to be flying around this circle, okay? Flying around there. Now the centripetal force is that horizontal component of lift. If we're looking from above and the aeroplane is banked on its side, that horizontal component of lift is pulling in towards the axis, okay? Now that's the centripetal force. The velocity, or the linear motion, is basically the aeroplane going forward through the air, okay? And what this means is as the aeroplane turns, it's always going to have this centripetal force when we're in a turn pulling in towards the axis, okay? So that's basically the horizontal component of lift. Okay? Required, basically, centripetal force is required for an aeroplane to actually follow a circular path. So that's something that's always present there whenever we're conducting a turn. Okay? And it acts perpendicular to the direction of motion, and the balanced turn acts in towards the axis of rotation, as we just talked about before. Okay? For example here, you can see the aeroplane here. If we back the aeroplane over, now this horizontal component of lift is the centripetal force, to put it practically. Okay? Next, in terms of some more principles and revision, we're going to be looking at the forces in the turn in a little bit more depth, okay? Now we talked about before, as the angle of bank is increased, we need to also increase the angle of attack to provide more lift as well. Okay? Now the increase in lift also makes up for the vertical component of lift lost during the turn. Okay? However, interestingly, the back pressure and the angle of bank is actually limited by the power available and the aircraft load limits, okay? Now I don't expect you guys to have looked at the airplane load limits in terms of the G's the airplane can take so far, but I expect you to know a little bit about the power available, okay? Now does anyone here know how much horsepower the Cessna 172 engine has?
No.
Okay.
I guess I'm guessing about
Yes.
300.
Okay, it's actually got 180 horsepower, okay? So significantly less than you'd think, okay? So we're going to have a look in a moment why it's limited by that power available. Alright? For example here, we're going to look at what we looked at before in a little bit more depth. So we've got the aeroplane here, this blue line representing the lift again, and this black line representing the vertical component of lift required, okay, to overcome that weight, or to remain in straight level flight. As the aeroplane tilts over to 30 degrees angle of bank, we require some back pressure to maintain that level flight. So all we do in the turn is increase our back pressure. Remember, bank, balance, and back pressure is how we enter a turn. Next, if we go any further than that, let's say now to 45 degrees, we need more back pressure as required, yeah? Okay. However, we also might require a minor increase in power to actually maintain level flight. Because remember, as we increase our back pressure, we increase our lift, we actually increase our drag as well. Now, if we increase our drag, we're going to slow down, therefore we can't create as much lift, and then we're going to get some more drag because we'll have to increase our back pressure even more. So it's kind of like a cycle there. So what we need to do then is increase our power so we can maintain the same speed for that back pressure. If we go even further, to 60 degrees angle of bank now, we have to double the lift, remember? So now we would have to increase our back pressure a lot, so a lot more back pressure. Then we're going to have a lot more lift and a lot more drag, so we're going to need a lot more power to overcome that. Okay? So we need actually full power required to maintain level flight in a 60 degree angle of bank turn. Okay? Now what happens if we move past 60, you can see every few degrees we move past 60, we need to increase the lift that we're making a lot. Okay? Basically, if we go beyond about 65 degrees angle of bank, we have insufficient power available to maintain level flight. That's because if we need to increase our back pressure even further, we need more power. If we're already at 60 degrees angle of bank, we can't really make any more power than that. So we'll be, if we go past about 65, we'll have full power, lots of back pressure, and we'll be slowing down and starting to descend. Okay? So that's just something we need to be aware of when we're actually doing these turns, that we can't really go past about 60, 65 degrees angle of bank. Okay? Now, in terms of the forces, in another way, we're going to be looking at balancing the turn as well now. Now, when we're actually in the turn, normally in a medium level turn, we're looking at balancing the turn more in terms of comfort. Today we're going to be looking at it in terms of actual efficiency when we're flying the aeroplane. Okay? So basically, to refresh us, balancing is represented by the slip skid indicator, okay, in the turn. Now I'm sure you're all remembering what this looks like, so we don't really need to go over this too much. An aeroplane not in balance is referred to as being either in a state of slipping or skidding. I think that will probably ring a bell from the last lesson. For example here, I've got an aeroplane in a 60 degree angle of bank turn. Bearing in mind this is what it would look like if you're in a 60 degree angle of bank turn to the left. Okay? And I know it's 60 degrees because in the G1000 or the screen of the aeroplane, we're tilted over in such a way that this triangle here is deflected over to this 60 degree angle of bank point here. So we've got 30 degrees here, which we're normally used to, 45 here, and 60 degrees angle of bank over here as well. Alright, so basically you can see this aeroplane is in balance because the trapezoid under the triangle is right under the triangle. Okay? Remember, we're not in balance if it's out to either side. Okay? So fairly simple there. Next, let's look at an aeroplane that's actually slipping, okay? So in this case, slipping out of the turn. If we look at the aeroplane from above here, the nose is pointing out to the right, and it's in some way, looks like it's slipping out of the turn. It's still following this path, but it's kind of out of balance. You can appreciate why that would be quite uncomfortable, okay? Alright, so basically the deflection of the slip skid indicator, you can see now is deflected to the left, and that means we need more left rudder, okay? However, unlike in a medium level turn, using a rudder in either direction isn't going to just fix it up. It actually might make some problems for us. Okay? So let's say, Tim, that I'm sitting here in a 60 degree angle of bank turn, okay? I maintain my altitude, yeah? However, if I use left rudder, okay, and the nose goes to the left, is it going down as well?
If the nose is going to the left, yes, it is going
Okay,
down.
see, for example, yeah, so if I fix myself up, if I make myself in balance by using left rudder, the nose is actually going to come down a bit, down towards the ground. What do you think is going to happen to our altitude then?
Then we'll lose altitude.
Okay, so we'll be in balance, but we'll be losing altitude. So what we can do then is, if we need to use left rudder in a left turn or right rudder in a right turn, we also should increase our back pressure as required to maintain that altitude. And just something to be wary of. When we go past 45 degrees angle of bank, using the rudders is actually going to create more of an altitude problem than fixing up our balance. So we need to use all of our controls together and coordinate them correctly. Okay? Let's look at another measure here. Okay? Let's have a look this time at an aeroplane that's skidding. Okay? So for example, this aeroplane is flying along the exact same path, okay, except it's following this exact same path. However, the nose of the aeroplane now is actually pointed in towards the turn. So it's kind of skidding into the turn. Alright? Now the slip skid indicator, Tim, which way is it deflected now?
To the right.
Okay.